Hello and welcome. I'm Bill Wake. We're here working on an old basic program. We're going to try and get it modernized. We've got it transliterated line by line, and we've done, I think, the mandatory work for loops, go subs, other kind of runtime support, and we've started working on the screen. I don't know. We'll see. Let's see. So I think we're still trying to get the test launched, so I think that's what slowed me down so much here. But we tried something to put a regular for loop in, and as I kind of suspected with Swift UI, the newish user interface tool, you can't just write a plain old for loop. You have to iterate over. Well, they have a for each, and they have a way to iterate over arrays and stuff like that. What we're trying to do is get a grid of objects. Let's see if I can. Well, yeah, this is probably close enough. It's all memory mapped, and we want to make sure that if anybody puts anything in 53381 to 54141, that we put a character up on the screen. And it's really, I'm pretty sure something I saw said 24 by 24. I just realized I didn't really count them. I guess they are blocks of 5 and 1 4. Okay, so it's not a very big screen. Each cell is a character and using character graphics. But right now we just have a long linear array of memory. And I think maybe what we need to do is make it a two-dimensional array so we can iterate over it easily in Swift UI. I don't know. Maybe this is worth a search. So Swift UI iterate over. Well, let's start here. Now we know we can do like modulo arithmetic and figure out which thing goes in which row and stuff like that. Hey, finally the tests run. Okay. But this has been flaky for me lately. Like, I never know if my line up here is going to let me talk to the search engine. Okay. And I do that every time too. Iterate over array. Yeah, so they have this for each, capital for each mechanism. You can put the array, you need an identifier, and yeah, you can stack them up and things like that. But I think what we're gonna have to do. Oh, there is a zip. We used that somewhere, didn't we? Let's see what zip is doing. Right, it kind of blends both of them together. That's nice. Like you can do a zip of an array to the array dot drop first, or whatever the thing to get the rest of the array is, and then you get the pair of elements with their successor. But that's not going to help us here. Okay. Let's see. So, is that the best way to do things? So, yeah, the question in my mind is, what if we turned our single array into an array of arrays, each array being one line? I don't think I have a way to break these up. I don't know. Let's see. For each. Well, I can type faster than that. And we had an example. Let's go back to that. Yeah. So just for each prints fields ID, and then and then the individual item. Okay, so we want to look at swarm dot screen, and we'll just say take the item as its own representation. Okay, and then this is all, and then let's put this in an H stack. Let's see, they go inside, don't they? Oh, can't remember. We'll try it. We'll get something out of it. H stack. And in there, we're going to put text with screen. Well, let's just do $0. So it's cannot convert value of nothing goes to H stack text to int. Oh, I guess I'll put cell in and then use cell. That nesting in the inside one, I think, messed it up. No exact matches. Oh. Okay. And then we don't need this, was my earlier attempt. HStack says put things horizontally, so this is not going to wrap by lines. I don't know what it'll do if it maybe just cuts off on the side, but we're just doing UI. We're not going to attempt to test it, although I know John Reed and a couple others have been doing some experiments around Swift UI testing, and maybe we'll decide that's worth trying at some point. But let's see. Okay, that's actually kind of promising. 32 is space, so we know. Well, if you were here yesterday, we initialized our screen with all spaces. Why the H stack is not... I mean, that seems to be the V stack, so maybe the H stack does belong outside. Excuse me. All right, so I'm just trying to wrap these things. Let's see if this works a little better. It looked like everything's stuck in a V stack, so I made an H stack of one item and then stuck them all in a V stack, apparently. So let's see if this is a little better. But I don't know what we can do on the for eaches. Let's see if there's some option that we can make useful. Yeah, we can do counts. Well, maybe we'll make that go. Let's see, where am I? The simulator, did I not hit run? I don't know what this is about. Oh. All right, well, I don't know. Where did everything go? For each cell in text cell, let's put something in so we can see it. I don't know. It's not promising. But what we can do, I guess with the numerical one, we could do 1 to 24. Oh, this is not good. Okay. We're not getting anything there. Okay. Well, let's try variation. 1 to 24. I'm just going to try and get this thing going first. id/.self text something. Okay. Well, let's do that first then. $0. Okay. I should at least see the numbers. Whoops. Did it? Almost closures. Oh, yeah. Okay. That's not really a cell, but just we can call it prototyping if it feels better than wandering around not knowing what you're doing. Okay, too much stuff, but everything's stuck horizontally. Okay. And is it counting up, trying to get to 24? I guess that's why the overlaps, it's got a little padding around them or something. Okay, I think we can... We have a horizontal stack, so this should really... These are each one's the rows, so we want to do this. And then... I think... Yeah, let's nest these things. Okay, I'm going to take that out. And then I'm going to do a for each. And oh boy, I think I'm going to have to do it this way. Even though okay. It's square, so I don't know. This may not be working. Okay. VStack. Okay, so $0 and the first one is let's say row in. And I think I'll just turn this off. And I don't need that either. Okay, a little more readable. Okay, so I'm just trying to iterate over the rows, print out each row, maybe even the word row, and then the columns. And these should be in an H stack. Okay. I'm expecting a gridish kind of thing. Okay, this is promising. I don't know why those characters... You would think I'd have room for 24 characters across or so, 34. Okay, but that's doing kind of what we want. All right, now, the thing it's not doing is it's not looking at anything in the screen. So let's get to the screen. Okay, so text, and we're going to take screen sub. Okay, so the row, it's really row times 32 plus column. Okay, and let's see what we get. Swarm screen. Okay. We should see a lot of 32s if it's how I expect it to be. Okay. 5, 10, 15, 20, 24, kind of. I don't know if we're seeing everything all the way to the edge. Boy, after a while, these look like little airplanes or something. They are 3s. Okay, but the padding is too much, so let's see what we can do for padding. I think we can do it on here. Well, we can do it higher up. I think if we do it on here, let's try that. Oh, what did I do? I'm hoping for a tighter pack, even though it will be wrong still. Yeah, not really. That looks the same to me. I don't know why it's hard to get my grid. Okay, but what do we have across? That's 5, 10, 15, 20. It might be squeaking 24 in. Well, what else can we try? Let's try dot scale. Let's try this one, 0.5. Okay, so the issue is not... I don't know. We're still getting all those 3s. They've just scaled a little nicer. Maybe I can do 75 just for improvement. Okay, but we are getting stuff from the screen. We're getting the numbers. And really, I don't know. Maybe our screen is just not the right thing. So the old character sets, let's get that up here. Where is that? Well, I have a subset. The stuff in the normal, like original US ASCII range, so 0 to 127, they basically used ASCII for that. So 32 is space, 33 is exclamation point, 48 is 0, 65 is A. Okay, but then the upper space, they made up their own characters. And somewhere I've got the documentation that shows every character and what we have. We're going to have to map these things in the upper range. And I don't know, it seems, well, I wouldn't be surprised if every little microcomputer had its own variations on these either. I think PET and Commodore 64 from the same company might have the same patterns, but I don't think anybody else felt constrained to do the same thing. Maybe they did. I mean, there were character generator ROMs. This is an 8x8 grid, so 64 bits times 256 choices. I think that fits in a 4K ROM. Like, exactly fits. Which cost real money back in the days, probably. Not now, where it's nothing. You probably can't buy 4K ROMs. Maybe they cost money again. Okay, so we're going to have to do something to map, like a 161 should look like a block. And in our case, a 238 looks like the little plane that is the thing we're controlling. So, but But these threes, I don't even get 32. I just get a 3. I get some space. I just don't want any space between my characters. All right, but that's not quite. So what I want to do, I think we can. Well, we want to convert this to a character. I don't know if we can just say character of some number. Let's see if that. Nope, something's complaining. String to character, no. Okay, let me just put it down here. Character. Content string description. Okay, that's not going to do it. And I know we looked at this the other day. Whoops. Oh, I'm supposed to be monitoring the chat. Okay. Let's see. Swift convert into character. Character of A plus I. No, that's not right. Convert it to a Unicode scalar and then a character. Oh my goodness. And it only works if you. Okay. Unicode scalar. Unicode scalar of the thing. Somewhere it should complain. Let's use that. So, I mean, I know I'm only putting in small stuff. Oh. Instance method require character to inherit from operator. Oh. Okay, let's take that back out. Is there another way? String format. Oh, Unicode scalar event of Unicode. Oh dear. Convert the integer into a string, then convert the string. That doesn't sound right. No exact matches. So let's try Unicode scalar of int of that. Again, I expect an exclamation point thing. Requires character to inherit from that. Well, can I do string character of that? And we'll clean this up. This is me trying to get my way through here. Now this may go look like blanks again. Yeah. Okay, but notice goes further down, so I suspect it's more realistic. All right, and then the go button, let's try swarm.print. Hello. Okay. Oh, shoot, that's not the action. Oh, that is the action. Ooh. Okay, this is progress. I mean, there's something about the spacing that we're going to have to work on, but I mean, in terms of can we see stuff showing on the screen from the intermediate thing, we're pretty good. All right, I think let's just take a 2-minute break here. We'll come back and see if we can clean that up a bit and make things move forward a little. All right, see you in 2 or 3 minutes. Hello, welcome back. All right, so what's interesting to me here? Well, okay, what's going to be tricky? Maybe I should go there. Go back to our program. So, I don't know, how are we going to make this run? It's like, I don't know if this needs to run in a separate thread. I hate to go to threaded stuff right away. But the relationship between the Swift UI and the code, I mean, what we want to do is just be updating this thing. Well, basically, the screen's going to update. We're going to change memory. Like, I don't know. Let's find there's a poke somewhere. Okay, so poke NA. So this is printing LA plus 47 and NA. I don't know what those are. Where's some other pokes? Okay, here's this one. Poke LL plus 23 times random of R. This is being written to the bottom, well, near the bottom row. So LL it's going to be 5, some 5-digit 5 thing. LL 54085. Okay, let's go back to our picture. 54085 is the starting point of this row. So it's throwing a bunch of random stars. So this is not a sophisticated alien attack. It's just overwhelming you with the numbers, right? The old video game tradition. Okay, but that's 0, times 23. Basically, we're trying to get random stars in this row. And the code's going to poke random stars, and we would like the screen to update at that point because we've changed the look of it. And then at some point, it prints and scrolls it up. So I think that means the run has to be asynchronous. But we gotta. Well, we have a loop, so it's not like we can't do anything. I just don't know. All right, so if we start this thing asynchronously, we want to do it in an alternative thread than the main thread. So like many UI frameworks, the main thread, all the UI action has to happen in the main thread. So when you hit go, we really want this to start running. And every time it pokes or prints or something, things should change. And we want to update the screen to reflect that. Now, and I want to do all this because I just want to get I want to get something showing. All right. Well, let's go to our to-do. What are we doing here? Okay, make basic screen show up in real UI. Well, that's kind of what we're at the primitive version of that. Yesterday was the 7th, not the 6th. Okay, so yeah, we've basically done that. It's got some refactoring to do, but translate basic to Swift, yeah, we've done that. Okay. Support the language semantics, we've done that. Simulate the environment. That's kind of what we're on. Then refactor. My goal is really to play with this program, not to spend all my time implementing some sort of thing. But all right, so let's create a method to character. It takes, let's just say, an int for now. and it produces a character. Okay, so Swift UI, the body has to be some view, but the you can have other functions. All right, and so I want to do this horrible mess up to here. Okay, of int. I think I'll call that value. Its type could even change. Okay, close, close. So I guess I'm going to return a string. String of character of Unicode scalar, and we need our exclamation point. Okay, because we know we're only going to do legitimate Unicode scalars for now. I mean, that's the working assumption. All right, so let me just duplicate this, and this whole string mess should now be to character. Well, that's a pretty bad name for something that's converting to a string. Is there another word we can use? Let's see it work, and then we'll worry about it. Does that look right? 1, 2, 1, 2. All right. Now this, I don't know if you picked up on it, but the rows are separated by 32 from start of one row to the next row, even though only 24 characters are visible inside. Okay, and go prints hello. Okay. That's good enough for now. We will have to do some work at some point. Like, well, maybe I can do that here. I think we should say return. In this case, well, life's a little trickier. There is no character that looks like my little logo character. Let's see if we can find something close enough that will get us there. Rightwards, leftwards, downwards. Can we use one of these? Yeah, that's kind of like it. Not the best thing out there, but okay. Let's make that our plane for now. Really, we can put images in, and we'll do that eventually. I mean, I suppose we could put the whole ROM in and, you know, get the literal exact old school character for each one. Okay. But I think we're going to have to do stuff like this to map it, which means like this probably belongs elsewhere. And we talked about maybe we should pull a screen class out, and I suspect that's true. I have a couple other programs I want to play with, so it makes sense to make the basic stuff separate from the environment stuff from the code we're working on, but right now it's not. Okay. Let's put that character in here too. Okay. Oh, gotta click the button. Oh, interesting. Okay, the character gets rerouted. It's probably, all right. Just for now, I'm gonna say we're gonna need the old delta wing. What's the word? The upside down delta is nebula. Nabla. Here it is. Okay. Okay, the real delta. Now, hopefully the font supports it. I don't know how we get a font that... They must have some default font. Yeah, another A. Okay, well, we're going to do V. Okay. So how are we going to make this go? So if you hit run, you make a bunch of changes. At some point, you have to notify the UI. And we did this with Topple, the last project. So you think I would know how, but at least I know where to look. Oh no, maybe we didn't with Topple. It was with the animation stuff. Let's go back. Shunt. Yeah, that should have it. Okay. So this project, we're doing algorithm visualization. So let's get content view. All right, so our go button says global async. We'll dispatch it on the global async. And then in the stuff, we must have... Well, where's monitor? Oh, there's a package which it appears to have lost. Well, where is that? I'll go viz. Okay. Monitor. Thread.run in main thread. So the updates to the UI need to happen in the main thread. Okay, so let's bring this back to ours. So we know this is where we're going to do our swarm run. But then anybody who changes, basically if you change the observable object, you need to run that in the main thread. Okay, so in our case, that's the observable. There's only one observable object right now anyway. Let's see. Well, one published field, I should say, screen. Okay, so anybody who changes the screen, which I think is just poke. Okay, so poke changes the screen. It needs to do that in the main thread. And I don't have a way, I don't know. Like UI, the threading stuff, it just isn't as good a fit as just straight up business logic. So let's go pull that here, and we'll just make our own thread plus run in main thread. And this is kind of a pattern for extensions. Okay, so now we know how to run in the main thread. Let's go back to Swarm. Okay. And let's find screen. Well, print is doing its thing. Let's take it here too. I mean, print could use pokes, but it's not. It's doing all this in here. Let's do a build, see if it wakes up and recognizes that. Okay. Let's see. I was doing screen row first. Yeah. Peak is okay. It's only poke that has to be careful with that. Okay. Well, let's give it a go. I don't know what's going to happen. I mean, what we're doing at this point, we're going to run our real program in a new thread and hopefully have made it so that it updates correctly on the main thread for the screen object. And I hope something shows up, like a star on the bottom row. Maybe, yeah, at least one star. I don't think we'll get more yet. Oh my. Okay, so something's happening. How you stop, I don't know. We haven't worked that one out. But what we're seeing is we hard-coded our random number generator to generate 0.42. And so every star of the 23 generated stars or 24 generated stars is showing up in the same column. And then the ship is there. I don't know, it's a little flaky visually, isn't it? Okay. Right. The ship's there. We don't have a control for it. I'd love to move arrows or something. I'd love to have a more random field of stars, but stuff's doing something. I'm kind of happy about that. All right. Yeah, so stuff's going on that we don't control. 57088. Where's that range to? That's somewhere totally different. 57088 is the keyboard stuff. 54157. 54157. That should be... Oh, that's just out of range. Okay. So what's a good next step? I mean, at least things are updating. We get these messages that we generated about peaks and pokes for good reason. All right, I think the thing to do... Let's go back to Swarm. Let's put a delay in here. We talked about a delay, but we haven't really done it. So let's delay what I think is 500 milliseconds. Let's delay 1500 so we can tell for sure. Okay, so I think this will give the thing a little time to catch up and maybe flicker less. Now, the little trail of V's after it, that actually was in the original. I definitely remember that. Um, all right, 1.5 seconds for every statement. It's going to be a while, isn't it? Assuming I've done my use sleep right. Okay. I think 500. Let's try 100, 250. A quarter second. Well, no, let's try 100. Got to go at least somewhat dramatically different or we won't see it. Okay, click go. There's the hello. Now, okay, stuff is happening. Star. Yeah. Okay. I'm gonna slow it down a little more. All right. So I think, let's see. We can commit this stuff. So what we're doing is run the interpreter in a separate thread, but update the screen in the main thread for the UI. Okay. That's cool. All right. And the delay, I think just to kind of let us see, the old basics weren't super fast. Okay. So now we got stuff that's not implemented and getting in our way. So I think that's the shift we're getting, that we're slowly getting things working. So I'm kind of assuming these things are fine, that we make assignments, and this is clearly fine because that's that. This is SP is ship. Okay. We poked 238, which was our V, so we are seeing that. These prints, that's a clear screen, basically. Interesting. I don't know why that's there. 85. So we print, we poke the ship in there, and then we clear the screen. That seems kind of like useless. Okay, so we'll have to see. So this chunk, let's see, LW, I don't know what that is. It's something about waves. LA is like the aliens. I don't know. We'll have to do deeper analysis. But one thing we can definitely make better is this. So 23 times random of R. Let's go to rand. Okay. Again, so we looked up the definition, and rand of some number says use the random number stream initialized with this value. If it's the same as last time, just return the next item in the stream. Okay, it's just a weird definition, but we can work with it. So Swift random in 1 to 100. I really want the 0 to not quite 1. Yeah, there's a lot of ways to do it. Random 0 to 10. Zero dot less 1. Okay, yeah, this is the kind of thing we want. We want a number that's 0 but not up to 1, and it's a float. Okay. Now, how do we initialize the stream? Well, let's get this. Let's do this much. Whoops. What was it? It was float.random in 0 dot less 1. Okay. Let's run again. Now, so what we're doing is we're generating random values now. We should see different stars in each row that gets printed. And we're not taking into account this thing of reset the stream or any of that stuff. We could, for sure. Okay, look at that. Random stars in your way. Boom. Okay. So that delay, I think what that tells me, we have a delay factor somewhere. I think 1,000. Let's triple that. Okay, and we'll run again. So I have no knowledge, no even beginning way to know. And the old things were written on 2 megahertz CPUs and running basic interpreter, so some factor of whatever to slow it down from there. But the thing to see boom and then see the score and the waves and the something else, that should have paused long enough that you could actually read it. So I'm just trying to tune that number a little bit. Looks like we're going to hit a boom here in a second. Okay. Score 280, waves 1. That's pretty close. Okay. Now, I think the font is not Courier, so we need a fixed width font on our stuff. I can't believe it didn't crash into that one. Just missed. Okay, this one looks like it'll hit. Yeah. Okay. And you can see why they used to have a Control C. Let's stop. I'm just going to bump that a hair more. Okay, and that's different than screen stuff. Okay, so what we've done is we made random, generate random numbers, adjusted delay factor. Okay, let's see. What else is going to go? Well, it's not much of a game if you can't steer, is it? But that's definitely trickier. Okay, so where can we try putting a font? The scale effect seems somewhat useful. I think we can give it a font. And I don't know how to do this. Monospaced. I probably have to do some sort of custom. Okay. I changed the font to Courier. Okay, that's a good thing. Font custom Courier size 70. We'll make ours a little smaller. And given that I'm choosing the fonts, I don't need to scale it anymore. That's such a long pause there. I don't know what's up with that. We should get a go button. Unless it's so big it's pushed the go button down. Let's try 10. There it is. Okay. Well, 4,000 might make it a little less challenging, but notice the V's are stable vertically, so that's a consequence of having a fixed width font. And the characters are readable, and they just about fit. So that's apparently the right size. That's a little small for my eyes. And they're a little separated horizontally. You can see the words are coming out a little funny. But it's progress. Okay. Let's stop that. We have use Courier for font. Fixed width. All right. Well, that nabla did not show up right, so off you go. I suppose there's probably some font I could set, but at some point we probably want to go to graphics for these things. Just to, the more realistic we want to get, the more we do that. Okay, to do. So we switched to Courier. We run basic in global thread, update in UI, and main thread. And we use real random numbers. Well, truly. See, I can't not say sudo. I don't know. I'm one of those people. Okay. I guess Courier was a little later. So I think we're still this environment. How we're going to do that? That's really the hang up at this point. Okay. Well, let me tell you what they really did, and then you see what you want, how we want to do it from here. Okay, the way you read the keyboard, you poke some bits into 57088, and those bits tell you which rows of the keyboard matrix do you want to read. So this is you have a wire, basically for every row of your keyboard you have a wire going across, and then for every column you have a wire going across, and then you connect them. Those little triangles I think are diodes, and so if you turn on row 1, so you turn power on row 1, and well, let's take row 2. You turn power on row 2, and you look at column 7, and if the Q key is down, that triangle is going to connect them. Okay, so you know, it's just a push. Your keyboard keys are just push buttons, and that's what's going on here. I think there's a diode in there that kind of keeps the current flow going the right way or whatever. But the trick to this is, if you want to read any rows, you have to turn on that row number in 57088. So if you want to look for the B key, you got to turn on row 4 and look in column 4. And for N, you got to turn on row 4 and look in column 8. Now, the thing I don't know And I did look around a little bit. I don't know if you like, do you set ones on the ones you want to read and then they have to be ones, or how's that work? I'm not quite sure. I did kind of look at the code and think it's trying to do B and N, which makes sense for left and right. These old keyboards I don't think had arrow keys. So let's see. Let's go find the code. So it's in Swarm. All right, so 530 turns off Control C, or turns it on. I don't remember which is which. I think I said on there. 1 turns it off. Okay, so you're turning off the basic handling of the keyboard. You're going down to the raw. I mean, literally down to the raw metal on the circuit. It's, you know, it's never that far from you when you're in an old computer. Okay, so we push 255. To me, I think that's saying let's look for any row, turn them all on. Okay, and if what happens next, you peak at 57088. So you just pushed saying turn on all the rows in the keyboard, and now we're going to peak. Okay, if X and 16 is 0 and the ship's in a certain range, then we're gonna decrement. So basically, if it's gonna go decrement, it's gonna go left if there's room to the left. If 16 is on. Okay, so 16, that's why I'm saying B. Column 4. Okay, now notice the way it's written. If X and 16, well, we just turned on all the rows, right? So if I hit T and Y, that would also work, or G and H. Okay, I don't think it cares. And my recollection is, and again, it may be off. This is a long time ago. My roommate who had this computer hooked up a joystick, and the way they recommended you hook up a joystick is basically you put a joystick in parallel with the keyboard, and so it may be that the joystick would effectively generate B and N, you know, for left and right or something like that. So I'm not 100% sure. I do remember you could play the game with keys or with a joystick. I don't remember which was harder. But basically we're polling to see if the character is hit. Now, I am open to whatever scheme we can come up with here. I don't feel like I have to do that. So, we've been going a while again. I think let's take another break, 2 or 3 minutes. We'll come back and maybe we'll just put some buttons on our screen instead of just the go button. I think we could put buttons for left, right, and stop or something like that. We'll see. So see you in 2 or 3 minutes. Hey, welcome back. All right. So let's get something working here that we can do to make this game go. All right. So my sort of first idea, or I don't know, I've gone around a bunch of things in my head. So you would think I'd have a better set. One thought, anyway, is what if you had 3 buttons that said go left, go down, you know, left, straight, or right? And I think what we could do is we could treat them as keyboard stuff. I don't know. We'll see. But at any rate, we're going to put 3 buttons in. The first one is left. I guess I'll put a little spacer between each one. Or do something. Spacer. I guess something like that. Left, it's down, and right. Okay, so let's see what that looks like. My thought is you would have the opportunity to press those buttons and they would update, they would poke the equivalent of that 57088 is my theory. Again, being so slow to start up just makes me nervous. All right, but yeah, my theory is we would click these. Let's see if as it goes. Okay. 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 So I think that's a step. Now the action is well, I think the action is I want to set the screen. Now the 57088 thing, that's going to be tricky. I somehow want to set this like a row and column, and maybe, what can I do? I could just set. Maybe I should set the row address, like a left should be row address is 4, column address is 4, and the end for the other one, and then maybe space or something like that. Or actually turn it off. Nothing. Okay, so I don't know if this is good or bad. Let's see. Can we drive a test that would do something? Let's try that. Okay, so the test I'm going to do, test poke. How about test peek to read keyboard? Okay, and so we're going to create the swarm object. I'm going to say swarm dot, do they call these, yeah, they're rows. Okay. Keyboard row equals 0. And keyboard column. These things don't exist yet. I'm making them up. 0. So I'm saying if anybody asks what's in the row, you're going to tell them 0. If they ask what's in the column, you're going to tell them 0. Okay. And now if you poke 57088, 255, and then let column, well, how about value equal peak, okay. I guess I did lowercase for unknown reasons. Okay. Then we expect value. Well, maybe I can just inline that. This to be 0. Okay. Okay, so keyboard row, keyboard column do not exist. Let's put them on. And again, in longer term, I expect to make this a configuration kind of thing. Var keyboard row of int equals 0. Keyboard column int equals, let's make them non-zero so we can test that we're doing anything. Okay, I think this test will fail. And I guess my to-do is changing too. It's really simulate keyboard. And I expect 42 to be in there because that's what we shoved in for a hard-coded thing. Right, peak is not implemented. Okay. Oh, 255. We poked 255. Wait a minute. We made a default return for peak that's 255, I guess. Sure enough. Okay. But we also got the message about not implemented somewhere in there. So I'll go by. There it is. Okay. So now I want to say if the address is 57088 and it's just hard-coded machine or operating system specific address, okay. What do we want to do? I guess we want to we just want to keep track of this keyboard row it's not keyboard row. So what I'm trying to make the semantics be, I guess I should be clear in my head. When we set these things, we're gonna, like, to get a B, we're gonna set 8. No. Why is it 1, 2, 4? Okay, we're gonna set 4 on. Well, let's do ends. We'll set a 4 in the keyboard row and an 8 in the keyboard column. And then when I do a peak, a poke, I want to keep track separately of these are the rows I'm going to be reading from in a moment. Okay, that seems right. Well, no, it's not quite. I'm going to do enough to get us through what we're doing, I guess. In real life, you can hit multiple switches at the same time. And the fact that you can, like, let's hit row 4, let's hit B and N together. Now we've got 16 and 8. So 24 comes back because we punched both those keys at the same time. But notice you can't detect everything. Well, I guess you kind of can. If I turned on 4 and 8, I could detect B and G being punched down at the same time. But okay, so the this is not keyboard row. It's a new thing. It's the keyboard. I guess I'll say keyboard poke equals. Oh, I'm in the wrong place. Let's do poke. Okay. If the address is 57088, the keyboard poke equals the value. and we'll return. Now, that does not exist. Just the fact that I'm scrolling tells you this thing is not encapsulated enough. Okay, var keyboard poke is an int equals, well, what is it going to equal? It's going to start 0. Okay, so keyboard poke. Okay, so if it's in the screen, we do the screen. If it's 57088, we set that as the poked value. And otherwise we print a message still. And this is, we'll just say like that because it's no longer just the screen. Now peek. What do I want to happen here? Well, again, it's if address equals 57088. We're going to treat it special. Okay, now what are we going to do? All right, so I'm thinking in here, here, when I poke the button, poke the left, I want to simulate typing a B. It's really yeah, I guess I want to say you are typing a B, so row equals 4 and column equals 4. And then when you do the poke, you're saying, I'm going to look in all the columns or all the rows, which columns are active. Well, only the one is going to be active. So I'm not going to simulate multi-key crunches because I don't know how to do it. And I mean, theoretically, I've got multi-finger tapping, but I'm not gonna mess with it. All right, so I want to say, wow. The peak. I guess I'm going to say the keyboard row is the active thing, and the keyboard column, if keyboard poke and I think it's this kind of thing. Oh, I don't know if I'm getting myself too buried here. If the poke and 2 to the keyboard row is set, then something. Keyboard poke. Okay, so you've pushed the keyboard row 4, and now we're going to look at keyboard poke, like we said, 255, and 2 to the 4th. And maybe, I don't know, if it's not 0, then we're gonna return. I think we're gonna return keyboard column. Otherwise, we return 0. Okay, so let's run our test. And I can deal with this off by 1 that I think I just introduced. And somewhere we got to reset those to 0s, not 42s. I hope I get at least a different number here. Maybe a 0. Well, I think it's going to pass. Let's see. Let's make the next stage. I think I probably jumped ahead a little. Okay. To read keyboard with some key down. Okay, so let's go for that end. So the row is 4. Well, it's 0, 1, 2. It's really 2. Row 2. Row 2, column 4. Nope. Column 3. Column 3. N. Okay. Now we poke 255, and the peak should be 8. 2 to the third. Oh. Apparently got to put those in front of your comments. Okay, so we got the keyboard row, we got the keyboard column. Row 2, column 3, we ask for any row, we should get 8 back, because column 3 boils down to an 8. Okay. Now, I think this test will pass. I think I already did enough work to make it pass. And assuming it does, I'm going to change 255. No, okay. 3 is not equal to 8. Okay, so we need to return basically 2 to the keyboard column. Okay, let's try that. And then I want to change 255 to something that's like 24, so we get a 8 and a 16. Okay, I'm messing everything up now. So this one is 2. Well, what have I done? Let's check these initializations. That should be 0. I don't think it's going to affect our test. 0. Okay. So peek and poke. Okay, on the poke, if the keyboard poke, oh, this is the peek. Let's do the poke first. If the address is 57088 and they push a value like 255, we just want to store that value because we're going to use it later. All right, then later coming in, we say if keyboard poke, okay, and 2 to the keyboard row. Could I be messing this thing up? 2 to the keyboard row. So if it's a row 2, we get a 4. If it's row 3, we get an 8. Okay. Keyboard poke and 8 not equals 0. Then we should get back 2 to the column. Okay. I don't think that's going to improve anything in my tests, but I think it's what I intended. A 1. Two is not equal to 0. It came back with a 2. 1 is not equal to 8. Okay, I guess we're going to take a break. Just take a run and break in here. Okay, we'll step in. We expect to end up at the address check, and let's print what's value 255. Okay, we'll step out, step in. Okay, how about a break on peak? So row and column should be 0. Value should be 255. Okay, let's go over. It should be. Okay, so let's print keyboard poke. Should be 255. Why it's in two places, I don't know. Keyboard row 0. Two to the 0 is 1. I guess I'm mixing up two things with my zeros. I was trying to make it so 0 was nothing on. I don't know if the special casing is so smart here, but I mean, if keyboard row is 0, well, what would that mean? I'm turning on this row. I guess that's supposed to be legal. I don't know. Do I want to flag it with like -1 or something? It seems... I don't know. What am I trying to do? Maybe I should be... Maybe I should be setting the flags that you want on. So if you want N, you better set 4. If you want nothing... Okay, so I think what I'm saying is turn on these rows. Yeah. So I think keyboard row, well, I can stop that. Like, what should I set in keyboard row? Maybe this is more the way it is. So if you are specifying which rows are on, you flip all those bits on, and then the poke says which ones do I want to get, and keyboard column tells you which ones really are on. Okay, so I think this is becoming more simple. No, if it is equal to 0, then you don't get a return keyboard column. Okay, so let's check the tests with our understanding here. Okay, so I'm saying no rows are on, no columns are on, you should get nothing back. This one I'm saying row 2, which is 4, and column 8 should be on, and you should get back the 8. Okay. let's try this. Okay. So we added a fake keyboard. Set bits on for active row column in keyboard matrix. All right, I guess the thing I didn't point out, these things aren't really, I mean, this is not really the way your rows are, right? QAZ space, that's not a row. XCV, well, that's part of the second row. You know, they're not an exact mapping. You don't have 7 rows of keys on a standard keyboard, and you have more than 8 columns. Okay, so now let's make this content view. So when well, okay, let me change something else as I do this. This is the keyboard. I don't know, I want to use the word fake, but we use that for such a different meaning. Keyboard. Well, what I want to do is turn it into a pair. 4-8. So maybe it's keyboard row column. All right. And that means I have to change up here. Oops. To change up here. And I have to change swarm. So this is going to become one thing. His type is a tuple. Okay. I can put the name in here. Keyboard simulated. Okay, and then content view needs to reflect that. Somebody needs to. Keyboard simulated dot row. Okay. Build succeeded. Great. Okay. Now let's well, I guess we'll run tests, but I don't anticipate a problem. Haha. Okay, keyboard simulated. So Simulate the keyboard. Okay, now our content view. So we're going to make swarm.keyboardSim equal row, and the less than we want to be, which was 4, 4, and 4. Row 4, column 4. This one, we're turning the keyboard off. And this one is the N. Is that correct, or is it? Yeah. Oh, sorry. This is 2, 4, 8, 16. And N is. Am I doing this right? I guess it's got to be 4. It is 4. Row 2, 2 to the squared is 4 and 16 and 4 and 8. 4, 16, 4, 8. Let's see what happens. Now what I want to happen is when I press the left key, it should just keep going left. Oh, I got them backwards. Yeah, it keeps going until I cancel it. I can believe that's not quite what you want, but boom. Okay. 540 waves 1. All right. Why am I backwards? The left. Well, let's change it and see what happens. I'm interpreting something wrong though. 4. Oh. This is 8, this is 16. Less than should be the B, right? Should be 16. 416 should be the B. Okay, we'll run it again. 54156. I don't remember what that one means. Now, I think the stars should be getting more intense over time, but I have to succeed. So I think in real gaming terms, you need to be holding these things down, and then they would be repeating. But when you let go of it, it should pop up. I don't know how to make that happen. I do want to cut the space out here. I think that's easily done. Okay. Let's take out this space and this space. Okay. And poke 1 at 530 not implemented. Let's special case that. Well, let's get this rolling first. Okay, just see if the I don't know if I can put an action that's like a hover over or something like that. That would be much. Well, you can't hover with a finger on your phone, I guess. Okay, that's going to be a little better, I think. Okay, our constant's probably a little slow. But notice, I think we're getting 1 star per line. And at some point, we should start getting 2 stars per line or more. There's a definite jerkiness to it. And I don't think the controls are perfect. Okay. Yeah. All right. Let's save this. Tighten up space in controls. Okay, and on our to-do, simulate the keyboard, we've kind of done that. All right. And I think what we need to do, what's next? Well, we'd like some button is a one-shot move. I don't know if there's something we can do there. This might be more accurate. It sort of feels like with the joystick, you know, while you were pushed over to one side, you were pushed, and it sort of automatically did it. But we'll pick up from there. Anyway, after that, we'll go back to the refactoring and try and work on it and make it more of a true Swift app instead of an ugly basic translation. And my schedule is in flux next week, so I don't think Tuesday, Wednesday, Thursday are going to work for me. I think I'm going to schedule it for Monday and Friday afternoon Eastern time. But if you're following this live, check on the site. If you're following it on YouTube, I'll still post videos whenever I get them done. All right. Thanks for joining me. Hope I can catch you again in the future. Bye-bye.